To understand soil and the function of soil, we categorise the properties of soil, and that helps us in science break down what are the different characteristics of soil and help us understand those characteristics so that we can classify soils into different types and associate with those different types different practices that will be most beneficial to the health and the productivity of that soil. One initial thing that's often done first is just to get an idea of the composition of the soil. And on a rough level, that just gives an indication as to what is the what that soil is made of. And generally, there's about 50% of the soil is made out of minerals, and they're the sand, silt, and clay. And where those minerals come from is that the local bedrocks get eroded by physical and chemical erosion, and biological erosion. So the wind and the rain and the chemical acids and the living things like bacteria and fungi can also break down that bedrock, and they create fine sediments that can be distributed through rivers and get flooded and distributed upon river valleys, or they can get pushed up by the wind, so you get sand dunes, so you get very sandy areas close to oceans. You can get the particles broken down and created into clays, especially when they're associated with forested systems. So in New Zealand, because we've got a dominance of forest, we get a lot of clay heavy type soils in our flatter areas. And then in areas which are flooded, we tend to get an increase in silt concentration, because as the river floods, often you get a deposit of silt in those river valleys. So you generally get a dynamic in any particular landscape where you've got the ocean, you tend to get sandier soils in the first few layers of big sand dunes away from the ocean. In the river valleys, you tend to get a more silt heavy soil, and then in the kind of zone between the mountains, so the kind of the foothills between the mountains and the sand dunes, you tend to get more clay dominated soil where there's heavy forest that's been established within that range there. So that tends to be the association with a particular landscape and the type of soil and what kind of composition it will be. And then if we look at the composition, there's also often, depending on the richness of that soil, it can be between 5, a really thriving, rich soil ecology could produce up to 20% organic matter. In many of our agricultural systems, because of the erosion of those systems, and because there's not much organic matter being replenished back into those systems and a lot of it being extracted out of it, often those agricultural systems drop as low as 1 to 2% organic matter, and the productivity of whatever crops or animals are produced in those systems is often only possible through the input of chemical fertilizers, because the organic matter's dropped so lower in those soils. But generally within productive natural ecosystems, the organic matter is between 5 or 20%. So if we can create an organic system that raises the organic matter up into those levels, it's going to be a lot more productive and function a lot better because of the higher composition of organic matter in it. The other parts are water and air. And that depends a little bit on the composition of the sands and silts and clays, because sands are a lot bigger than silt, and then clay is just tiny. So if you've got a lot of clay in your soil, there's less water and air in it, because the particles are so close together that not much water and air can penetrate into it. Whereas if there's a lot of sand in the soil, there'll be a higher proportion of air, and depending on how much water is in it, water also, because there's bigger gaps between those particles, so air can get into it more easily. one easy way to gauge the proportion of those sediments is just to do a float test. So when you mix a soil sample with water, so you can do this in a measuring cylinder if you like. It's quite handy if you do say 100 ml sample of water and soil sample mixed together. So generally I'd add 100 mils of soil with 100 mils of water, so that the whole sample is 200 mils, and then the soil will be up to 100 mils. And then you can take a percentage out of 100 quite easily that way. And what will happen is that as the sediments settle out of the water, they'll create bands. And the heaviest one will be the sand down the bottom, and then you'll get silt, and then clay, and then organic matter on the top. And that can give you a quick assessment of the composition of sand, silt and clay and organic matter within your sample. And if you've taken a 100 ml sample, you can just read them straight off the measuring cylinder. So if that's 20 mils of sand, then that's 20%. If that was 40 mils, it would be 40%. And again, if that was another 20 mils, it would be another 20%, with maybe another 10 mils of organic matter, so it'd be 10% of organic matter. So just by using measuring cylinder, you can do the percentages quite easily. You can then use the percentages that you get from a float test like that to determine the type of soil you have. So for a soil pyramid, to be able to do that, you have 3 axes to the pyramid with sand, clay and silt, with 0 to 100% sand, 0 to 100% clay, 0 to 100% silt. And you can plot your values from a float test against this to then determine what type of soil you have. So if the sand was 20%, it would be about there, and the axis for sand run parallel to that, so they go up that way. Clay was about 20%, so it'd be about there. The clay ones go straight horizontally, and then the silt was 40%, so it'd be about there, and the silt axis runs that way, so parallel to that line. And where all 3 of them intersect is the type of soil you have, so this will give you a reading of your soil type. So in this instance, it's going to be a sandy silt loam soil. And a loam soil equals a good balance of the different types of minerals. And what that means is that each one of these minerals has certain characteristics. So the sand, for example, being a bigger pore size, will allow air and water to flow through it quite easily, which means it will warm up earlier in spring because it won't be so waterlogged. It will allow, in winter it won't get so waterlogged when it rains a lot, because the water will drain through it more easily. But some of the drawbacks of sand is that it will dry out more easily in summer because it can't hold on to water so effectively, and the sand doesn't hold on to nutrients very well, so it will also be a bit of a nutrient poor soil. The silt, being of a smaller size than the sand, has the kind of physical properties that it will hold water more effectively, but of being a smaller size, it won't allow air to flow through it as well as sand will, but still quite well. So I have kind of intermediate air porosity or the ability of air to flow through it, it will have quite good water holding properties, but it can still get quite waterlogged with excess water. But again, it doesn't have the charge, which is unique to clay. Clay has a negative charge on it, and that negative charge helps bind to the positive charge of the soil minerals, so that clay can bind to positive minerals in the soil. And that binding helps store those minerals in the soil and act as a reservoir of those minerals to support plant growth. And that's called the cation exchange capacity, or CAT. So cation exchange capacity. And that's really a measure of the amount of clay that's in the soil, which will bind those minerals, but also the organic matter, because organic matter too has that negative charge that can bind the minerals in this soil and store those minerals in the soil to make them available to support plant growth. Some of the drawbacks though to clay is that because it's such a small particle size, it doesn't have good porosity, it doesn't allow good air or water movement through it. So that means it really holds onto water and can create flooding, particularly in winter, because the water will drain away quite hard. And because it's quite fine, if you stock the paddock quite heavily, it will compact that soil quite easily, or if you have heavy machinery on it, and it will create hard pans of clay where it's very hard indeed for water and air to move through that layer. So if it's a loam soil, it means that there's a nice balance between those different types of particle types. So in this case, it's got a dominance of silt, which is a nice intermediate size. The 20% sand will kind of improve the porosity, so the ability of air to flow through it and water to flow through it, so it doesn't get waterlogged, and there's good air movement through it to support life processes within the soil. But the 20% clay will also allow it to hold on to a good amount of minerals in that soil to support an ongoing plant growth within that soil. So a type of soil with that proportion would be considered the ideal kind of agricultural soil, because its raw proportions of minerals is the most beneficial to support production. But no matter what type of soil you do start with, you can work with that type of soil by improving the soil biology and storing organic matter in that soil to improve the characteristics of that soil and allow it to hold more water, to hold on to minerals, and to allow water to flow through it more effectively, just by increasing the organic matter and the life that's within that soil. So the physical properties really is just understanding what is the mineral component of that soil, so how much sand, silt and clay is in it, and what will be the characteristics of that soil as a consequence of the mineral component.